Happy Tuesday. Hopefully you had a great 4-day weekend. You enjoyed some sun, got to spend some time with your family, and just kind of enjoyed slowing down a bit. So this week we're going to be working on using scatter plots to find lines of best fit. So today we're going to be completing an inquiry lab that is on page 675 in your book. I want you to do this with me. So our question is, how can I use a model to predict an outcome? Sasha and Stacy found the data below showing the winning times in the Olympics for the women's 100-meter freestyle swim. They want to predict the winning time in the 2024 Olympics. So you can see at that data table that years since 1956 is actually 0 on this scatter plot. So then 4 years after 1956, which would technically be 1960, is represented right here. And then 8 years after 1956 is represented here. 12 years after 1956 is represented there. So this table is a little different than what we're used to because 0 actually represents the year 1956. So now let's go on to our hands-on activity. The first thing we have to do is to construct a scatter plot by graphing the points years since 1956, time. So remember, when we are graphing, the first one is always our x, y, which means years since 1956 is our x. So this in our table are our x's, and then the time is going to be the y. So these are coordinate points, these are coordinate points, and so on. And then this is just another row of coordinate points to continue the data. So the first one, we have 0, 62. So 0 is my x, and then I'd go all the way up to in between 60 and 64. And then 4 is my x, so in between 0 and 8, 61 and 2/10. So just a little bit above 60. And then we have 8, 59 and 5/10, so just a little bit below 60. And it's okay if these aren't perfect. You're just kind of estimating where it should be, but it should be pretty close. So go ahead and pause the video and continue to graph those. And then push play after you have all of the x and y's graphed from 0 to 52. Okay, so hopefully you have your plots graphed. It should look something similar to mine. Again, it's okay if it's not exact, but you should still see kind of when you're reading it from left to right, you should see kind of a decreasing pattern because the dots are getting lower and lower on the graph. Some of them go up just a little bit, but it should look something pretty similar to mine. So step number 2 says use a piece of uncooked spaghetti to make a line that goes through most of the data points. So the reason why they want you to use uncooked spaghetti is because it's nice and straight, and we want a straight line here. So if you put a piece of spaghetti that kind of went through most of your points, it looks something similar to that. It would obviously be a little bit straighter. How close are other data points to the line you drew? So using that piece of spaghetti, my line goes through some of my points, but it doesn't go through all of them. And that's okay because this is a line of best fit, what best represents the data. You could see that there's probably 4 or 5 points that actually hit the line. And then there's probably like 4 or 5 below the line, and then about like 3 above the line. So it's about in the middle because there's enough data above than there is below. So it's kind of equal to the ratio above the line to below the line, and then there's some that are on the line. So for step 3, I'm not going to scroll down because I'll lose my graph. But step 3 says, look at the point where the spaghetti has an x value of 68. The corresponding y value represents the projected winning time in 2024. So when our x is 68, that represents 2024. So I'm going to go over here. It looks like I need to extend the spaghetti a little bit. So this is 64, so this last one is 68. And if I looked at the value of y at 68, it's right there. And that is about 44. So the point would be 68, 44. If yours is like 48, 47, something like that, the book actually says about 49, so my line's a little bit off, but somewhere in the 40s probably. So what is the projected winning time in 2024? It's about 44 seconds, 49 seconds, whatever you have. And then the last part says, refer to the line drawn in the scatter plot. Is this method always going to be valid when making a prediction? And the answer is actually no, because realistically, if I continued that line on forever, I'm going to get to a time of 0. Well, you can't swim 100 meters in 0 seconds. So realistically, it wouldn't always work, and even 44 seconds is pretty extreme time, so it'd be a little difficult to meet. So your answer for that last question is no, it won't always work, because at some point it's going to be too small to be realistic. All right, so your homework assignment is to take a picture of this page that we did together, 675, submit that to Google Classroom, and then on that same assignment, you're going to complete page 677, the real world link. I'll get to that page and show you. So this page right here, you're going to do this real world link. You're talking about cookies, I think. And year 0 represents 2000. So then 1 would be 2001, 2002, 2003, and so on. So you're going to do 1 through 3, take a picture, and submit that picture on the same assignment that you submit page 675.